back again. It is Saturday. So today we are going to look at data transmission, but I was supposed to send the videos on Friday, but I wasn't able to. Today we are going to look at data transmission, which is a chapter you might know about it very well. Very well that this chapter contains the revision series, and this chapter doesn't contain any maths problem. Just you are doing is what, just transmitting data. So this is a data, and you are just transmitting those data to another somewhere else. So if some in the computer or something like that. So let's look at those, how we actually do that things. Um, so as you can see, this chapter in this one over here, what we are looking at is the syllabus. So this is the contents, like the main introduction contains like what types of data and methods of data transmission. So how do you the methods for transmitting data. So we are just looking at them, and also how many types of data transmissions are there. We are also going to look at them. So there are some notes over here. We must read it no matter what is it. So this topic syllabus is very much easier than any other thing. Let's move on to the next thing. So next of all, as you can see, over here, this is also a syllabus. Just read the syllabus 2 or 3 times. Read the upper part too, and understand only what it actually wants. So let's move on to the next one. So packets. The most important thing is, what is packets? They're the small unit of data. So they are only the small unit of data. You must, if someone asks you what is the meaning of packet, you must say that it is a small unit of data. That's it. And what does packet contains? It contains the sender's and receiver's IP address, or they also said destination IP address or any other thing like that. Destination IP and receiver's IP, like whatever it sends, it's called the sender's IP, and whatever it receives, they are called as receiver's IP. And the packet number. So the packet number. So the header contains the packet header, or we can say it as header contains the senders, and receiver's IP and the packet number, and another one is packet number. So the IP and plus packet numbers are the header contents that it contains. Alright, so then here we have packet payload, where in the packet payload we call it the actual details. So, and the actual details are inside this packet payload, and in trailer it ends, marks the end, like this search, they check out, or they actually like what we said what we should say is, they actually like check those datas line by line, the receiver's IP, if it matches or corrects, or if it's correct or not. So that's why we call it as the mark the end. So mark the end means the sender's and receiver's IP address and the packet number is checked, and also the payload's and actual data is also checked. If there is a mistake or something like that, this trailer will actually check, like mark it. They will find it out, and then they will mark it and find it out, and then they will use error checking methods to recheck the things, or re-output the things, or they will do a lot of things. Like in error checking methods, most of the things are actually like checked or fixed. They're actually fixed basically. So if the sender's and receiver IP is wrong, or the packet number is wrong, or the actual data is wrong, that time this trailer will mark the end, mark the things, like whatever the mistake or whatever the errors in these packets are, these packets will be checked by the error checking methods. So there are some error checking methods, we are going to look at it. Next we have is packet switching, the most important part. The packet switching is the most important part, and there will be 5 to 6 mark question over from here, and you have to actually answer all these points whenever they will say 5, 4, 6, like whatever the mark of answer they will give, you must actually like give every points, like don't ever miss any points. So data is broken down into packets, each packet is sent across the network, each packet takes separate path, and you must like put it in the next point. I mistakenly didn't give it. Then a router controls the path of the packet. Router examines each packet and sends destination address, and sees their destination address and sends it to the fastest route. When the last packet arrives, they reorder. So there is a packet. You can see like how the packet is designed. They will give you a diagram to draw. They will say you to. They will tell you to draw the diagram, and you must draw the diagram. Next, let's go to the next one. Next we have the methods of transmission. So what are the methods of transmission? Serial, parallel, simplex, half duplex, and full duplex. They have drawings and diagrams, so I will show you to the next page. Serial is the data sent down in a single wire, single beat at a time. Obviously, data is sent single wire. They will be sent in single wire, then single beat at a time. So they will send the data with a single wire, and each of in each wire they will send each data, each at beats. They will send the beats at a time. Alright, done. You just have to memorize this, nothing else. Like read and read so that you will be able to understand and memorize it. Because they will give you the simple definitions for memorizing them, nothing else. Alright. Then we have parallel and parallel multiple wire, multiple beats at a time. Simplex is just data sent down only one direction. Half duplex is sent down both direction and not at the same time. And full duplex is both direction at the same time. Okay, so there are some diagrams, and whatever I have said told you must you will be able to actually understand what are these diagrams meant in the definitions. And these are the diagrams, and I will, after finishing every chapters, I will give diagram notes so that you will be able to understand what are the diagrams they want from you. Alright, so there are some advantages and disadvantages of serial and parallel, simplex and duplex. So these are the advantages and disadvantages, and you have got it. So data won't be skewed, there are less chance of interference or error, the transmission speed is adequate and cheap, obviously slower, because like they are sent single beat, single wire, single beat at a time, that's why. And in the simplex, as you can see that the simplex, you can see that quick, no requirement for converting to serial, and more, and there are some more advantages, like parallel is usually 5 millimeters, meaning it is good for short range. Parallel used among PC components, and data transfer speed is fast. And the disadvantages, more chance of interference and expensive when data is good. Okay. Alright, so we have serial bus. So this is the ending of 1.1 series. Alright, so serial bus is, you have understood that serial is sent down single bit at a time. So that's why single wire serial is what? Like serial is what I have shown over there, I think. Wait, serial it means serial means single wire, single bit at a time, obviously I have told us now. And universal serial bus means the same thing. They are going to be sent single bit at a time. So what is it? Like a serial bus, as you can see, USBs are serial bus because they are one direction and one, and they will send data one bit at a time. So as you can see, that standard connection uses serial data transmission that designed to transmit at high speed. So they are sent data at high speed with one single bit at a time. So used in industrial standard ports, comes in pre-installed, does not need external power source and high speed, and feeds in one way, less chance of error while connecting. Okay, disadvantage is limited to 5 meters, and high speed isn't high speed as Ethernet. So Ethernet is a type of network connection where their data is sent more faster than the universal bus. Alright, um, because it comes with electricity and stuff like those. Like, we are not going too much depth, so that's why we are just going to remember these stuffs, because you must read and read and read so that you'll be able to understand any of this. Alright, over here there are errors, methods and errors of data transmission. I'm going to finish this chapter in one day, because in this chapter there's nothing to like nothing to do something. So nothing to do is nothing. So over here just you have to memorize the stuffs, nothing else. So you just have to memorize them so that you will be able to understand them, and you will be able to write every questions and answers what they ask for. Alright, so several then error detection methods. So error detection method, error checking methods that trailer wanted. So you must remember what the trailer wanted, the error checking methods. So what are the error detection method and the error checking methods? Error checking methods are the same thing. Okay, so whatever the detection or checking method, whatever it is, they are the same thing. And by using these error checking methods or error detection methods, you are able to understand what the problem is. So there might be some background noises, just you have to ignore it. And let's move on to the next one, which is about the so what are those? Like parity check, checksum, and echo check. As you can see, like, I would recommend memorize 4 to 5 or 6 marks, because over here a lot of points are there. Just you have to remember, like, what I should say. If you are better to remember everything, it's better, because in exam you don't know how much marks you're going to get. But after you do some question papers and answering them, like, I will answer every of this question like this way, because this is very much better to this is actually written in a way that, like, I would say that this type of answers are actually mark scheme answers, but I have, like, decided to take some mark scheme points from there, and then like, I have organized them properly, and you must memorize step by step, because the points are actually, like, all points are actually, like, serialed by serials. So that's why organized, like, points are actually organized. So if you're okay with understanding them, then you will be able to memorize them. Alright, wherever data transmission is being on, either it's 0 or even, parity is chosen, and you can see that number of ones are total. 8 bit parity is, parity bit is achieve the set parity. Data is sent, receiving data receives the data. Like, they will give a diagram or something like that, and you must also draw that diagram according to what are the points are given. Okay, so let's move on to the next one, which is the error checking methods. The error next one is the checksum. Like, what are the checksum is talking about? So in checksum, as you can see, a value is calculated, 4 to 5 marks, answers will come. I am telling you several times, like, if you are memorizing all the things from here to here, then it will be easier for you to answer everything. But I would recommend 2 question papers, so that you will be or topicals, so that it will be easier for you to understand how much marks they they're talking about, or what I should say, like, what the mark scheme wants. So that's the thing. I have actually, like, taken some mark scheme points and organized them, so that it is easier for anyone to cope, anyone to understand or something like that. Okay, so echo check. Okay, first time let me show you what are the points are given. Before transmission takes place, an algorithm is calculating for the modulus 1, modulus 11, and then data is sent, then data is transmitted, and receiving device, same method to check the checksum, calculate the checksum, and if it matches, then it receive the checksum. Calculated checksum is with the received checksum. If it matches, then no error, else error. Okay, so whatever things, just you have to do is memorize, nothing else, just memorize it. Echo check, the same thing over here. Like every points, if you look at every points, they were sending device sends the data, receiving device receives the data, the same thing. Like just you have must write the first introduction points like that way. Like the introduction points are different, like what are the approaching points are different, but otherwise whatever the sends what are the sending device does, sending device sends the data, receiving device receives the data, nothing else, they're not changing names. And then in the last part, if the data is if same data, then no error, else error. Like in every error checking methods you will find this, the same things. So let's move on to the name number 4, ARQ, automatic repeat request, or they will say automatic repeat query. So query or automatic repeat request, or we can say it ARR or ARQ, whatever it is. So when the error is detected, data is need to occur and you transmit data, and if error is detected, and positive or negative. There are two ARQ methods. One is positive acknowledgement and another is negative acknowledgement. Let's look at it, what they ask for. What they ask for is, in the positive acknowledgement, a timer is started. Sending device sends the data. I have told you, like whenever you are approaching any question of these error checking methods, you will find out that data they will first say sender sends the data, receiving device receives the data, then whatever they ask for, then you will in the last point you are gonna see if data is same, no error, else error. Like this way you will find out everything. Like in the first point you are actually approaching point, you are writing the approaching point, then you are starting with the sender sends the data, the receiver receives the data, and in the last point you get it what is, like if the data is same, then no error, else error. Like those things are same, you must keep them same, and whatever the middle part or in the body paragraph says or in the approaching point says, just you have to memorize those. This is the only trick you must remember, because otherwise you will be facing a lot of problems. And I would just say read so that, and do question papers, and so you'll be understanding it, everything. In the negative acknowledgement, it's the same thing. Like in the first point, sender sends the data, receiving device data, then you must include the like what the negative acknowledgement points, what are they wanted, and in the last part you must include that if the data is same, then no error, else error. Alright, we're done with the acknowledgement, and now data entry error detection. So this data entry error detection method, so the first part we covered was the error checking method. Now we are checking the error entry error method, like validation. You must have heard about validation and validation. So validation is used by this, and validation is a different thing. Like you put two input values and then enter the thing, whereas in validation you just use check digit methods and then you answer those. Alright, in this one I'm just showing what are the things. So you can see that in way, if same, then it's correct, if not, error in the entry. Like the same thing, like if the data is same, then no error, else error, like that way. Like you like this structure is different, but the same thing. If it is a type of validation, and already it's written over here, used to check error in the entry. A check digit is values previously calculated, and from data using algorithm like ISBN 13, a number is stored with the data. When data is entered, it is calculated. Like over here they are not telling about the sender sending the data, receiving device sending the data back to the sender. Like they are not actually they're not asking for those, but in the first points and the last points, if you look at it, like if the error if same, then it's correct. If not, like these things, these 2 points are same. Otherwise, just have to like you just have to like memorize the approach, or read and read, so that you're able to get those points what they actually wanted. All right. And obviously do question papers. Like I'm going to give a question paper class. Last time I have actually, like in the last video I have done a question paper class. And over here now, the error detection methods. The most important process of, oh wait, I have mistakenly gave, oh this was supposed to be the encryption. Anyway, I'm going to over here there will be another syllabus thing, which is 2.3, and this one wasn't the syllabus. I for mistakenly put this one over here second time, third time. I will actually like what I should do is just recheck the syllabus and put the syllabus of encryption. I will put that syllabus, and then you find it in the drive link below the description box. And next we have encryption. And in encryption, done to make the data secure. So this is the main point, like done to make data secure. Encryption is done to make the data secure. So in any call, voice calls or something like that, or in the video calls or something like that, you find that there is always written this call is encrypted, this video call is encrypted. Because why? Because so that the data packet is not hacked by any user, and they will not find out what you are actually telling to that person. Because if they find out that what you are telling to that person, they might track you or something like that, or they might got your location, and then they will come to you and kill you or something like that. So encryption of that company use that code of yours to see what you are doing or something like that. They are not actually doing what you are. They are not looking at your things, but they are securing your stuffs. That's what. So if the packet is hacked, data becomes meaningless. Data before encryption is plain text, and the encryption key is the algorithm used. Ciphertext is the same is the name after encrypted. Can be symmetric or asymmetric. So there are two types of encryption: symmetric encryption, asymmetric encryption. We are actually done up to. We are almost done with the chapter. So let's look at it. Yeah, we are actually done with the chapter almost. Let's look at the thing. Like this chapter is very small, and if you see, like we didn't actually do that much. That we didn't have to do much. It didn't actually take too much time for you to understand what are the things. Just you have to read and read to memorize it, memorize it, so that you'll be actually able to answer any questions from these chapters. Alright. They will actually mix up the questions. Like in symmetric encryption, they will add something like that. In symmetric encryption, they might do some adding stuffs like that in chapter 3 and chapter 2, like that way. Or they might actually like do something more crazier in the past papers. So over here, let's look at it. Encryption is used key, encrypted using key. Like symmetric encryption uses key, and ciphertext is sent with the keys separately, and keys used to decrypt data back to the sender. Like that, they are actually like telling it. So you can see that plain text and then encrypted, and then encrypted. After encryption, they use the secret key. These two secret keys for encrypting and decrypting. After, if the hacker gets the secret key, then they will decrypt the key, and they will get your data or something like that. So this is basically easy for hackers to intercept both keys and cross the network, and less secure. So that's why nobody uses this system. And we actually follow right now is the asymmetric encryption. It's a long-term use because it is used small scale, and this one is used at large scale because your data needs to be secured. In cybers or something like that, you will use them mostly. So plain text is encrypted using public key, and ciphertext is transmitted decrypted using private key. As a public key using useless, just keep it in the bracket because I did actually like mean to write this one. Just keep it in the bracket. Then two different keys used to more secure and used at large scale. All right. Next we have is, as you can see that in the graph, the diagram is shown over here. In this diagram, as you can see that public key is used for the encryption and private key is used for the decryption. The plain text is sent and then it's encrypted, and this is also decryption using the private key, because now hackers will not be able to, if the hacker gets the public key, they won't be able to get the things. If they get the private key, if they don't get the public key, and if they get the private key, then they will decrypt the data, but they will not get the encrypted key. So in encrypted key, whatever it is sent, they will not get it. In the public key, whatever it is sent, they will not get the private keys things. All right. So thank you for, like, as we have completed with the syllabus. I will say that I will make a past paper, I mean topical section. As you can see that I have in the front page I have sent that we will do some topical questions and answers, like how we approach them. I will show you that. And from now, just read the chapter properly so that you'll be actually able to understand whatever the things they wanted, whatever the things they said, whatever the thing is. Just also read the syllabus and revise the series, whatever I have given in this revision series. Alright, so thank you for watching. If you have liked this video, please subscribe to my channel, because I am waiting for more people to get my points, what I am actually like meaning to everyone. So thank you for watching. Take care.